This is your host Sapni Bhartia, and welcome to another episode Let's Talk, where we are doing a series on LF energy projects. And today we have with us Sander Jansen, product owner at Virtual Substation team at Alliander and technical steering committee at CoMPAS. Sander, it's great to have you on the show.
Thank you for having me.
Let's just start with some of the basics. Let's talk a bit about the CoMPAS project. First of all, it's a kind of an acronym. So what does this word stand for? And then we'll talk about what problem you're trying to solve with this project.
So CoMPAS stands for Configuration Modules for Power Industry Automation Systems.
Excellent. And what is the scope of this project? What is it all about? Of course, there is a lot of explanation in the name itself, but let's talk about what it is about.
Yeah, so the main goal of the LF Energy CoMPAS project is to configure and design 61850 configurations for substations and other 61850 related applications such as DER control or controlling medium voltage substations. And yeah, they even 61850 is even used outside the utilities, for example, in the hydro power industry.
Can you also talk about the history and origin and genesis of the project, where it was created and how it moved to LF Energy?
Yeah, so the project was basically created inside LF Energy. So the folks at the RTE, they said, hey, we have some issues and some challenges around substation automation, and we like to build a tool for that. So we had some sessions together with other industry partners to discuss what such a project should look like and what's the focus. And after that sessions, we had an initial roadmap. You can find it on GitHub. And then, a couple of months later, we starting the actual development. Yeah, we decided as Alliander to join that development because we think it's important to have a good management of your 61850 configurations, because they're becoming more essential part of your business. They contain logic, functions, etc., and that's what you want to keep track of. Because if you want to control the grid, then you need to know what control circuits are in your grid, so that you can prevent any feedback loops that are not working so well.
This whole industry is going through digital transformation because a lot of things are changing in the industry. The way we consume electricity, we are also becoming producers of electricity with all those solar roofs and all the electric vehicles. Can you talk about how is it creating new challenges as well as opportunities for substations? And also, if you can talk about what kind of transformation substations are going through.
Yeah, so the challenge we're having as a utility right now is that we see more and more congestion on our grids. So if we want to connect parties to the grid, we need to come up with clever solutions to do so. And if you look at the electricity grid today, you see that substations are major hubs where energy flows combines and goes in and out. So what do you want from a substation right now is at least measurements, so you know where the congestion is. And in the future, you might want to also steer a little bit more on the substation configurations. So for example, you want to change the frequency settings, maybe you want to dynamically change the protection settings. And that's all to just connect new parties to the grid that are not connected to the grid in the classic old-fashioned copper way of working.
As you said, your title is that you're product owner at Virtual Substations, and we have seen in other spaces as well where a lot of things are getting virtualized. We have seen that a lot in telco space, where they are moving from hardware to a lot of virtualization is happening. Can you also talk about what kind of virtualization is happening in substation space?
Yeah, so in the substation space, you see a strong separation between the configuration and the actual deployment of substations. And the CoMPAS project is focusing on the configuration part, which is essential if you want to move towards automation of the actual substation function itself. So there's another LF Energy project, so-called LF Energy CPAS. And what they try to do is also have a operating system and a layer on top of it to virtualize also the automation function itself. So think of measurement collection and also protection functions virtualized on a generic computer.
Let's go back to CoMPAS project. Let's talk about what kind of community is around the project.
Yeah, so the main contributors of LF Energy CoMPAS today are Alliander. We have two full-time developers working on it. RTE is actively involved. They joining as well. And we're also collaborating upstream with another project, so-called OpenSCD. And that's run by Omicron, which is a vendor of 6150 testing equipment.
If I'm not wrong, the project is almost a year old or so. What kind of growth, what kind of adoption you have seen for the project in these couple of months since it was created at LF Energy?
Yeah, we see some rising interest from other utilities. I think they're all part of the dream we want to achieve or the goal. But we did not see any active contributions yet. The most utilities are currently in the stage of asking, hey, what's doing? Oh, interesting project. We need to follow this, etc. But that's a good start. We're asked on conferences to give a talk. So there's definitely interest from the utilities.
If I look at the project today, it's an active project at LF Energy. Can you talk about what are the things that you're working on right now, or what are the things that are in your pipeline that, hey, this is what we have to work on, or this is what we have to achieve?
Yeah, so what we're working on right now is getting more insights in 61850 configurations. So in our case, we do have 61850 configurations, but I like to have them a little bit more exposed because they contain a lot of valuable information and it's currently limited use. So we want to have more insights in existing 61850 configurations. So that's what we're building on this quarter. In the past, we're building a database where we can store 61850 configurations, and the folks at RTE, they actively working on generating 61850 configurations based on templates, and they have an entire process for that. And they want to release that as open source as well.
So we talked about the ecosystem. We also talk about, that how it's being used. But I'm also kind of curious if you can share what kind of use cases are there for the project. Who are you targeting? Who are the users of it?
The main target audience for the software are engineering companies or utilities that do engineering. So what the software currently allows is that you have your, for example, your IEC SIM data model, where you draw your substation or the substation to be, and then you convert it into 6150, add functionality to that, and then we use it in the substation. And once the data comes back from the substation, you got all the measurements in perspective.
Can you also talk about, either the complexity that is there for utility companies? How do you make it easy for them to kind of either interlinkage between utilities and grids and the whole data management and configuration? How easy or difficult it is for them?
Yeah, so currently I think if you want to tackle congestion management, it's key that you know what are the measurements points, what's being measured, where is it being measured, how it's being measured. And that's where LF Energy CoMPAS comes into play as well, because based on the configuration, you know where the measurements is done and what logical node did it, so you can trace back to the source. And that will help you to do some more analysis and also to find out if a measurement is not right, what's going on. It's a source. It can help you with that.
Sander, thank you so much for taking time out today and talk about the CoMPAS project, its scope, its of course history and evolution, and also what kind of problem it's trying to solve. And once again, I would love to have you back on the show. Thank you.
Thank you for having me. Have a nice day.